Okay. All right. Today we have a paper which is, the first author is Eduardo, but his colleague is David Anderson, one of the other people. And I've asked David if he would be so good as to moderate the session rather than myself, since he has he needs to do something. He is an author on the paper, really. Okay,
Yeah.
David, over to you.
Yeah, well, thanks, Jane. So we were just having a little conversation before everybody joined, and we were talking about how we got connected. That is Eduardo and I was telling Jane that Eduardo had essentially reached out to me when he began working on this paper because he had some questions about the whole sensitive periods, critical periods concept that he thought we could discuss together. And he invited me to join as a co-author on the paper. So I was really excited because this is a topic that has fascinated me for quite some time. And it was fabulous for me to see this particular study because studying critical periods or sensitive periods is really, really difficult and really complex. And yet Eduardo and his team had been doing this fabulous 3-year longitudinal study that, and this paper is one of the results of that. They've published several other papers that are connected with it as well. So I won't say really much more than that because Eduardo's got all the details that need to be shared, but I'll come back at the end and help to moderate the questions and maybe give you some more of my perspective on the whole sensitive periods, critical periods issue and why I think it's such an important topic for us all to be aware of and why I think we need to figure out ways to do more research that addresses this issue of whether such periods actually exist, and if they do, what sort of implications they have for promoting skill development. So with that said, I'm just going to hand it over to Eduardo because I know he has a lot to say, and then I'll jump back on towards the end.
Okay, thank you very much, David. I would like to start by thanking the consortium by inviting me to present this paper. In particular, David, it was the one who approached me. It's a really honor to be here and present this difficult work. I promise, David, that I won't speak about the reviewing process. I will leave that for the other time. So the name of the paper, the title is "Are There Sensitive Periods for Skill Development in Male Adolescent Basketball Players?" And this is actually a doubt that we still have. This is a great concept. Is an interesting topic, but it's really difficult to study and to be sometimes sure of if there exists of if these sensitive periods doesn't exist. But let's move on. Okay, so the menu for today is I'll try. I made some questions and I will try to answer them. The first one was, what are sensitive periods? Why they can be important in youth sports? How do we identify them? What is the available information about this? The aims. Then we move on to the aims of our paper, the participants and methods. And finally, I present the results and some take-home message. So this is the main question. And before answering or trying to answering that, I think it's important to know that probably these sensitive periods, they emerge from this concept, the critical periods, and they are more or less related. And the theory behind these critical periods, it contains that the organization of a system is most easily modified during its time of most rapid development. Early conceptions, they suggest that these critical periods are typical short in duration, they occur early in life, and they mostly lead to irreversible changes. However, the most recent evidence they have been suggesting that this period, in contrast of what was believed, they are rarely brief and they seldom lead to reversible changes. That's why contemporary researchers, they prefer to use the term sensitive periods when they're referring to heightened periods of sensitivity to environment inputs. So moving on to sensitive periods, these concepts, it is believed that there are specific time periods during which an individual is most susceptible to environmental influences. These are periods in which several changes underlying physical growth, biological maturation, and development occur more rapidly and efficiently. They are also known by windows of opportunity, and they are definitely closely associated with the readiness concepts. Today I will not speak about it, but Professor David has a lot of work on this, and where he relates the critical periods, the sensitive periods, and this concept of readiness, if you are interested. The way I see these periods, they are mostly seen by at least three lenses. One is that time periods during which an individual is most sensitive to learn a particular skill or acquire new skills. A different approach is there are time periods of accelerated improvements in motor abilities. And in third place, there are some authors that believe these are time periods when training has an optimal effect. That is, optimal times to improve, for example, physical capacities and skills. So, why they can be important in youth sports? It is believed that motor abilities or specific skills are more trainable within certain temporal windows if coaches implement the proper stimuli. There is also belief that athletes may never reach their full potential if coaches do not properly exploit such windows of opportunity. And finally, the potential existence of these periods might significantly affect how coaches design and implement their training program. Sorry. Having this in mind, most probably having this in mind, when in 2004 Bali and Hamilton presented for the first time their model long-term athlete development, this is inspired in these ideas. I believe they proposed and they started to include it in this model, these windows of optimal trainability or windows of opportunity. For those who are not so familiar with the long-term athlete development, also known as the LUTAD model, this is a youth athletic development model that is used by the Canadian government. He has different versions, as you can see here. In 2013, the authors released an entire book about this model, and is mostly known by these different stages: active start, fundamentals, learn to training, training to train, train to compete, train to winning. And nowadays is also a different approach, not only to the youth or the sports not only for the competitive sports, but also to stay active for life. This is why in 2019 the title also changed, is now long-term development in sport and physical activity. And if you read it really carefully, you will find a small chapter devoted to these windows of opportunity. And this is the image that the authors include in the model, where they suggest that when we align our data by biological age, as you can see here for males and females, there are some windows of opportunity to develop, for instance, skills. And the authors suggest that skills in males are the most optimal time to develop skills are before the PHV, peak height velocity. For instance, in strength, the authors suggest that the optimal time to develop strength in males is after the peak or the attainment of peak height velocity. I'm saying suggests because there have been a lot of criticisms to not the model as a whole, but this idea of windows of opportunity, because in none of these versions the authors present any empirical data to comprove or show why they make these suggestions. So the lack of empirical evidence, it's real, and that's why this is one of the papers that criticize the model, but there are plenty of them. So how do we identify sensitive periods? I made a summary of this, and the first thing that we need is longitudinal data. That's a fact. So high sampling frequency is important. For example, every 6 months, like we did. Second, we need a mathematical or statistical procedure to identify peak height velocity, and there are some options available. For instance, in the Saskatchewan longitudinal growth study, they use the Price-Baines model. In Levine, in the adolescent growth and motor performance, they use the Vent-Off method. So there are different ways of identifying peak H velocity, but this is important. And third, use a biological marker as a time metric. Because we deal with males, we use H at peak height velocity. Some authors use H at menarche, and there is also possible to use H at mid growth spurt, as I will show after. So the available data, it's really limited. In non-athletical adolescents, this is probably the first study that's aligned by a biological marker and biological age, different types of components, of performance components. This is as I used to call the green book from Bannon and colleagues, and is and has a summary of the research project that they implemented in the 80s. But this is one of the starters of this idea. 10 years later in Spain, Yagan de la Fuente also did a similar study, and also for boys and in this case for boys and girls. So they try, when they align the data by months from peak height velocity, they try to find peak spurts also for different kinds of tests or physical components. In this study with Brazilian children, this is actually one of the first of our group. It was published in 2019, and we also use data from boys and girls. And as you can see here, for instance, we align the data of hand grip strength by biological age, and we try to find these peak spurts for different type of physical components: hand grip strengths, standing longitudinal, jump, shuttle run, and 12 minutes run. And this is one of our first papers about this subject. I'll just this is another one, also with non-athletic adolescents. I'm the first author of this paper. I did this. I wrote this paper while I'm doing my PhD. Probably my supervisor thought that I had enough time to do other things, and we, in this particular paper, use data from Canadian, Brazilian, and Portuguese boys only. And the idea was the same. But here there is this cross-cultural idea, and we're trying to see if in different countries, and even with the time lag between the three studies, if the peaks are coincident or no. It was a good challenge. as I said, this is all, there are also some data with non-athletic children. Instead of using age at peak height velocity, we used to use age at mid-growth spurts. I will not detail this, but these are 3 examples of papers that we wrote and as in our group. And now, finally, when we arrive to athletic adolescents, there are only 2 studies that use this approach. The first one was in soccer, youth soccer players, adolescents players, only males, and it's from 2006, and the idea was the same. Okay, different tests, different components, muscular components, aerobic, endurance, etc. And this one is the first with young athletes, and this is the second one available. This is a paper from my PhD, and we use the data from the basketball male, but only the muscular strength information. So sit-ups, hand grip, medicine ball throw, squat, jump, and contra movement, and the idea was the same. And after I finished my PhD, I thought, what about the sport-specific skills? And there are no studies about this rather than this one that I'm presenting today. And that's why it was so difficult to write it, so difficult to discuss our findings. But we did it, and I think we did a good job. But there are no other footprints in skill development. The aims of the paper were twofold: to examine the development, timing, intensity, and sequence of basketball specific skill spurts, and to define putative sensitive periods, windows of optimal development for each skill. And this was something that we had from this previous one. Here we only identify the peak spurts, and here we try to define these windows of optimal development, because we always try to challenge ourselves, and this is an idea that I think it's related with the first aim, for instance. So moving on to the methods and the origin of the data. The data come from this larger research project in X study. This is a print screen of the website. That's why it's in Portuguese. I'm sorry, but this was a really large research project that we implemented in our faculty. We followed over 3 years young players from five different team sports: basketball, handball, water polo, volleyball, and soccer. And we follow them for 3 years. Not only players, but also the parents, coaches, and then we also get information about the clubs. So it was a big thing. And in my PhD, I used some information of coming from the index. This is the research team, just for you to have an idea. We have a PI, co-PI, the main responsibles for each sports: basketball, these 2 over here, Patricia from volleyball, Danielle from soccer, handball on the right, and then we had a colleague responsible for the psychological domain, the biomechanics, and also these 2 external researchers that help us a lot during these years, Professor Mark Williams and Professor Adam Baxter-Jones. In the next study, just for you to have an idea, we have data from 758 players out of the 1,000 expected. We expected 200 per sport, but for many reasons it was not possible. We follow them in December of 2017, 18, and 19. And this is a summary of the data that of the sample that we have from different sports. and players were assigned to 5 cohorts, 11, and in baseline 11 until 15 years of age. So in 3 years, we could have information from 11 until 17 years of age. This is about the INEX study. But in basketball, in which we have data from about 300 young basketball players, it was the only sport that we did a different thing. In order to study this kind of idea of sensitive periods or peak spurts, the basketball, it was the only sport that we collect data 2 times per year. And that's why I have here June, December, June, December, June, December. And this was purpose for me to be able to do these kind of studies. The one that I'm presenting now is a good example. And in my case, in the basketball case, so we have data from 11 years of age until 17.5. But as you can see here, for instance, in cohort 1, players that joined the study with 11 years of age, we have data from then until 13.5. Those who joined the study at the age of 12 until 14.5, and etc. About the study domains, the INEX study, it has 4 domains: biological, skill, game proficiency, psychological, and contextual. Of course, it was impossible for me in my PhD to use all of this data. I only used data from 3 of these domains, and this particular paper only used data from anthropometry and technical skills. The young basketball players, they were submitted to 6 different field tests. And as you can see here, from a larger research project to this particular paper, I only use a small piece of it. In this video is just for you to have an idea what he did. We actually, all the players, all the 58 players, they come to our faculty. That was a good thing for us. And these are examples of what we did in anthropometry, body composition. These are a video from the pilot study. Some of the tests that we performed, the psychological questionnaire that they all had to fulfill. And these are some examples of the field tests: the physical performance test, skill. This is the yo-yo test, the t-test, agility. This one is actually is doing in the wrong way, but as I said, it was a pilot study, so that was good for us. And here are some of the basketball skill tests: the slalom dribble, the passing, is the sprints. We also film them playing 3-on-3. This is the shooting test. This one is also one of the skill tests. It's called defensive movements. All the jumping were done using force platforms with contra movement and squat jump. And a small portion of our sample also uses eye tracker because some colleagues were interested in this data. But I didn't use any of this information. Just for you to have an idea of what we did during 3 years. Okay. On the statistical analysis, to be able to do this kind of studies, not only the one that I'm presenting today, but also the ones that I showed you before. We are using this software. Peak growth is not available because we asked a mathematician and a software programmer from the University of Porto to develop that for us. The peak spurs were fitted using the mathematical generalization of the vent-off method. So we use the method that Professor Bana also used, but since the next study is a mixed longitudinal study and we have to deal with missing data, we ask the software programmer to develop a mathematical generalization of the method. Mean velocity curves were defined in terms of biological age, as you already saw, months before and after PHV, peak height velocity. Although measurements were taken every 6 months, this method allows to estimate velocities every 3 months. And this is the thing that we have on this paper in contrast to the others. And we had to make a decision, and we try to have a decision most objective possible. And so our sensitive periods were conceived as the period between maximum gain increase before the peak spurt and maximum gain lost after the peak spurt. This was the way that we develop these sensitive periods or windows of optimal development. Onto the results. We will start with heights, but before, just let me say this. Although we have data from 293 basketball players, in this study we only use data from 160 because we needed complete data on 5 to 6 time points. So our sample is a little bit smaller, but for you to have an idea, the study that I show you with soccer players, they had 33. So it's really not easy to have this kind of information, and I think 160 it's good for what we have available, and all of these players come from 20 of the 20 basketball clubs. This is the usually peak height velocity curve. Some highlights: our peak spurts in height was identified in 159 out of the 160 basketball players. So the software was able to identify the peak height velocity for almost the total of our sample. In some studies, this is not the case. And on average, as we expect, we are dealing with men, with males. So players attain PHV at 14 years of age on average. That was more than expected. The figures from the peak spurts of the basketball specific skills are here. So one figure for each test: shooting, passing, control dribble, defensive movement, slalom dribble, and also slalom sprint. And here are the highlights. Apart from the slalom dribble, this one over here, where the maximum gain occurred 12 months before the peak height velocity, all of the remain skills, the peak spurt happened or was attained or 6 months before or coincidence with the peak height velocity. So as I have here, maximal gains in skill development occur mostly coincident with peak height velocity or within 6 months of its attainment. Although objectively marked, the size of the window of optimal development, the gray area, varied substantially across skills. Here is really narrow in shooting and passing, and in some other skills this gray area is more wide. But as I said before, we had to make a decision here, and the decision is valid for the six different skills. While we were writing the discussion, we thought that it will be a good idea to present a summary of the available information, and in some way comparing with the suggestions made in the LUTAD model. So this is a table that we show in the discussion, not on the results, but I think it was good because in this side of the table we have for the 5 different components, the 6, sorry, no, 5. The one that is split 1, 2, 3, 4, 5, 6. But speed, as you can see, has speed 1 and speed 2. So this is what the LUTAD model proposes, and here is the windows of opportunity that they suggest. And on this side of the table, we have the empirical data from this study and from the other study that I present with muscular strength, and also the information from the young soccer players. And as an example, in the LUTAD model for strength, the authors suggest that the optimal time to develop strength is after peak height velocity, and in our case, and also in the case of Renat Philippart, for this particular test, we found our data, the peak spurt for this for this physical test, it occurred coincident with peak height velocity. So the suggestion and the empirical data, as I will present now, there are some divergences. About the skills, the main topic of this paper, the LUTAD model, they suggest that skills are mostly developed before peak height velocity, and our data in soccer there is no skills, as you can see, no information. But in basketball, our data shows that 6 months before or coincident are the most usually peak spurts for skill development. So as an highlight, our empirical results appear not to corroborate with the LUTAD suggestion. However, our findings cannot refuse this suggestion because of the lack of data 18 months before peak height velocity. And this is one of the things that Professor David mentioned, and in one of our discussions, I'm moving backwards because, for example, here in PASS, as you can see here, I don't know if you can see my mouse, right? Probably. As you can see here, this looks like we have a peak here, but we have no data to comprove that. But we left this in the discussion because I think is important. Take-home messages. So peak spurts in performance for most basketball skills were observed when peak height velocity was attained. Maximal gains in technical skills are most probably linked with increases in muscle mass and with high levels of physical performance. And this is a conclusion that comes also from the paper that we use, muscle strength, because peaks in that study were coincident with peak height velocity also. So these physical skills and physical performance are most probably related. And the multiple peaks observed within the defined windows of optimal development suggest that there is always room for skill improvement, even if gains might be greater early in practice than later. Of course, not only the INEX study, but also my PhD were possible because we had some funding, the Portuguese Institute for Sports and Youth, the Portuguese Olympic Committee, and this is our national our national funding agency, and they didn't support the INEX study, but they also support myself as a PhD student. I had a scholarship. And of course that I have to thank not only the 5 Porto associations, basketball Porto association, the soccer, volleyball, etc., but mostly and most important of all, these are the names of all volunteers, students, master students, colleagues, some professors, my sister is in here, my wife. So as you can see, a research project of this big, we need a lot of people involved, and all of these persons were volunteers, and I will be forever thank you. Thank you for your attention. I'm happy to answer positive questions that you might have. Thank you very much.
Thank you, Eduardo. Maybe you could stop sharing your screen right now so that we can all see each other. We may need to go back to the presentation, I guess, if people have specific questions on specific slides. But thanks again. That was magnificent. And as I said at the start, I felt really honored to be included as part of this team on this paper, because this study is just incredible, the INEC study. I mean, the logistical challenge of developing and then executing this study just blows my mind. And the number of people who are involved, again, it's such a complex study, but you've now got a treasure trove of data. And I'm sure, we've already seen some publications come out of it, and I'm sure there are going to be a lot more publications following on. But our task at the moment is to focus on the findings that Eduardo presented for this component of the study. And I figured, rather than me jumping in to say something specifically now, I'm wondering, Jane, did you want to take organizer's prerogative and ask the first question, and then we can open up to everybody else? And of course, you can either put your hand up using the function in Zoom, or put a question in the chat and we can read it out via the chat.
Well, first, Eduardo, I'm very impressed with the study and all your colleagues. I've never seen an acknowledgement list of 2 pages so small. But as we all know, we couldn't do our science without a lot of people helping us, including wives and girlfriends and sisters and so on. So it's very impressive, as David has already said. I would like to ask a sort of sideways question, because my field is really motor development, and Bob Molina and I used to have long discussions about the role of biological maturation and things like that. But if you were going to design a study in which you looked at other, like relating the various aspects of skill development or parts of the skill development towards the final attainment, in order to do some of the things you have to run before you can change direction and things like that. Have you ever thought about how you might think about that slightly differently in terms of looking at the other kinds of motor skills that get you ready to learn the next, because we talk about fundamental skills and then we talk about sport-specific skills, etc. So yeah, I know that that's not on the paper. It's just
I know. That will be for sure interesting, because until you reach the sport-specific skills, there are many different levels that are below that you have to acquire and develop. We never did that. Probably we don't have the data. I think it will be important. Because those studies that I show with the mid-growth spurts, that in children, they are only about physical components. So there are no data on skills that we could look at it, but I think it will be interesting.
But even looking at the relationship between the skills that you do collect the data on, not just the time of peak height velocity, but actually looking at agility and then looking at shooting or something like that. I mean, in other words, these are all related to each other. in a sort of factor analysis kind of way, but
Yeah.
they might also be able to predict where you might be going too, that if you get to a certain point, at this point, they might be related.
Yeah,
That's
and
fun.
in a different studies that we perform, in some of them we look at the mean skill development of these 6 skills.
Yeah.
And when we run a multi-level model and we include, for instance, physical performance or an overall measure of physical performance, it of course that is related.
Yeah.
Those who are physically fitter, they have a better skill performance.
Right.
That's true, and we are seeing that.
Right. So again, I want to commend you, and this goes back to David, on distinguishing between critical periods and sensitive periods. Thank you very much. I can't tell you how many people get that wrong in our field. So, so it's very nice, and I would just recommend that everybody have their students read that paper. So thank you.
Yeah.
Over to you, Matu.
Thank you, Eduardo. I'm almost speechless, but since I'm not a co-author on your paper, I can fully say this is work of the highest standards. You have fully opened the box here. That is a magnificent example of how a fundamental question can lead to so much implications for the people working on the field. I find that impressive. And this is also my first question. Now, you have been modeling based upon a very nice number of athletes, but the coach on the field has his team. And within each basketball team, there's a huge variability in lengths and where these athletes are in their developmental stage related to, for example, peak height velocity. Now, how can he benefit from this work? I think we all know we cannot expect that the coach is going to determine the moment of peak height velocity of each of his athletes and modify the individual programs. It's a team sport. That's a little bit difficult. What would be your suggestions if I would present this work to our basketball federation in Belgium, for example?
Yeah, and I think it's not a. Thank you very much, first of all, for the words. I believe that it's difficult to separate these findings from the actual peak height velocity because there is so much increase in muscle that leads to physical development, skill development, and etc. And I agree with you because if I go to a coach and I say, hey, I want to test this, I want to implement a different program, and half of your team will do the program, half of your team won't do it, and you'll say no. You just say no. So, but that will be the I think the next step. Try to intervene. But
I was just thinking what you have measured here are individual skills.
yeah.
An idea could be that you propose to a coach, okay, you have part of your training is on individual skills and a part is on team activities. The team activities can still continue with the whole group together, but you might think of more differentiation when it comes to individual skills or other aspects of development like speed and strength or stamina and so on.
Yeah, and also a thing that I think would be interesting to look on is because in this paper and all of the papers that I show, they present mean peak spurts, right? But it's possible to do this for each athlete and try to see, okay, I have 100 athletes. They all reach the peak at the same time or don't? It is possible to do this, but the problem is some players might don't reach that peak for the software to identify this as a peak because the model implies that. But backing to the coaches when I discussed the differences in biological maturation in basketball, we do, for example, a lot of work they're in separate boards. And if a coach knows, okay, I have a team of under 16, of under 14 players, and if he knows where are the players related to the peak height velocity, he might, like you said, even in practice, there are team practices.
Mhm.
When we perform a 3-on-3 or 4-on-4 or whatever, if he knows who they have in front of them, they might separate some of these athletes.
Yeah. Okay, it's very nice. I will leave some time for the other speakers too. I just wanted you to know that during this presentation, I have added your paper to the list of mandatory readings for my students. This is really something they must read for me.
Thank you very much.
Excellent. I'm so happy with this type of work. Thank you.
So
Thank
we're
you.
glad we're able to help you mature with your teaching. But I think the similar questions, if you look in the chat, David, I think it's sort
Yeah, I
of a
was gonna
follow-up to the same thing.
Yeah, I was going to say the two lab groups have asked a similar question in terms of what are the implications for coaches of this work, and we kind of got into that already in the answer to Mathieu's question. But I guess more broadly we could talk about I guess what's currently happening and in the coaching context and how we think things would change more beyond what we just talked about, given these findings.
I'm sorry. Now I got lost. You want me to look at the chat? Sorry.
No, you don't need to look at anything. I'm kind of summarizing what's in the chat because
Oh,
the two questions in the chat,
okay.
build on Mathieu's question about like the implications for coaches. So it looks like a lot of people are interested specifically in what coaches are going to be able to do with these findings now, and what might they do now that's different from what they've been doing up to this point in time. And I think you've touched on that already in your answer to Mathieu's question, but I'm wondering if there are any other things that you would add to that in terms of implications for coaches.
Yeah, I believe if coaches are aware that these periods might exist, or if they are aware that probably we could use the peak height velocity to develop a strength skill, if I am a coach of under 14 team, I have to be aware that, okay, maybe this is an opportunity for me to improve these different skills or physical components. But as I said, we need a lot of more work on this to be sure. And as we said in the paper, we cannot confirm that these sensitive periods exist because the information it's very limited, but we cannot refuse it. So I'm not really sure. And sometimes it pisses me off because I have a paper and I wanted to, but I'm not really sure. It's
I can add something in a minute, but I see that Phil Kearney has a question in the chat, and he quotes directly from the paper, and I'll read the quote and then his question. So the quote is, players who showed higher levels of technical skill at the beginning of the study had less room for improvement as practice continued, given that the skills had diminishing rates of return from practice and ceiling effects. So his question is, did you explore the influence of initial skill level in your data? And could you please speak more to this?
Yeah, we have a different paper, and that one is on my PhD. I can send everyone. Is a tracking. It's a paper on tracking on skill development, and what we did was we used the idea of development canals, and we have the players there are in skill develop. Can I share my screen? Let me.
Yeah, you can still share it, Eduardo.
I think it was easy. can just open it. Because that quote is related to the findings of this paper, and that's why I think it's okay, if you don't mind, of course, for me to. Can you see the paper?
Yes.
Yeah. So on this paper, what we did was use this idea of development channels.
Just kill the left side so it gets bigger. So hit the X there. Yeah, I got it.
Sorry.
Now, and then you can increase the size down there. You go.
Okay. So the idea was, okay, we have this idea of stability, players that in the beginning of the study, the one is the baseline, and here is our 6 time points that I show you. And this is idea, stability in skill development, players who during the 3 years of the study, they are all always on the upper canal, players that are always on the middle canal, lower canal, and some players that when the study began, they were in the lower canals, and they move, so positive instability and negative instability. Players that got worse over time. And this is what we mostly show. So the skill developed, it's really erratic. And to answer the question, we also have this idea here, and sorry, upper canal, and here is we compared on this study also the players who were on the upper canal with players who were on the lower canal, and what our findings show is that the players who are always on the upper canal, they have a different profile, a different physical profile. I was trying to find, and I don't have it here. I'm sorry. I thought I had a figure here. But sorry, going back to the question. Yeah, the idea was that so many players, they were already on the upper canal, so they cannot improve on this particular test. That's why we quote the ceiling effect. But that was also an idea that we look it for. I don't know if I answered the question. I thought that we had a figure on the paper. I'm sorry.
I think it does, but let me add something to this that connects with the point that Jane made earlier, and that is when we look at the precursor skills to these sport-specific skills, what we don't know is what happened before any data collection in this study.
Mm-hmm.
So obviously we know what happens once the data begin to get collected, but we don't know what happens prior to that. And if you think of this in the context of sensitive or critical periods, usually we think that maximum gains are going to happen, but particularly when we're talking about skill acquisition, we're going to see the most rapid changes in performance at the beginning. You know, it's the classic negatively accelerated learning curve, right? We see big gains at the beginning and then diminishing returns. So knowing when somebody actually first got exposed to these skills is important, because it'd be really good to know where the start was relative to where they were at the first data collection point in the study. I think that will be really informative. And again, back to your question, Jane, about how do we potentially look for these sensitive periods and these precursor skills, that becomes really, really difficult now, because in Eduardo and the team's work, they're looking to align changes in skill acquisition to biological markers. And if you're using changes in height, then you've got an opportunity to do that at peak height velocity and at that mid-growth spurt, but you don't really have a biological marker that you can use other than that, which is why most of the work previously on sensitive periods for skill development have been age-related. So they focus on when is the child first exposed to the sport, and then how quickly do they make progress. So for example, we did a study quite some time ago where we analyzed the records that have been kept by a swim school, and that swim school had really, really comprehensive, detailed records that showed when children started to take swimming lessons, how many lessons they had every week or month, when they achieved specific criteria, because they got a certificate when they hit certain benchmarks and then progressed to the next level. And we analyzed how many lessons it took for the children to reach these specific levels as a function of when they started to, when they were first exposed to formal swimming lessons. And the interesting thing in those data were that the older the child started, the faster they learned the skills. So, you know, if you looked at, for example, I think it was like the 2-year-olds compared to 8-year-olds, it took the 2-year-olds 4 times as many lessons to get to skill 1 level, well, the skill 1 criteria, than it did the 8-year-olds. So there was this, you know, again, sort of diminishing returns there in terms of the time that you need to invest in training to get to a specific level. But it's, I mean, this is what fascinates me about the whole topic. It's such a complex question, it's such a difficult one to study. And, you know, I think Eduardo and his team have really taken a really major step here to figuring out how we can study this kind of in the natural context, but knowing too that we need to figure out how to do some experimental work to really test some of these ideas, like true experimental work, not more of this sort of quasi-experimental work.
But I would just add, it's a multivariate problem. And right now you've got it sort of as almost a univariate problem. And I think if you could somehow find your mathematician to figure out a way to put this all together. Remember, I'm a dynamical systems person, so I see this as many variables, and what is going to be the control variable that will push you over to the end, but what's the readiness of these, or this sensitivity, as you say, to a period of things. There was a follow-up question to Phil. Do you want to, is he still here with us? Phil, can you unmute yourself and ask your question directly? Thank you.
Can you hear, I hope you can hear me. Actually, I might just follow up on your point, Jane, if I might, just because another piece I think would be fascinating on that. I know that the conversation is about quantitative analysis, but I think it would be absolutely fascinating to look at the time period and to have a qualitative analysis of the developmental experience of the players, their changes in perceived competence, in motivation, in practice, across the time period that you're studying, and almost to map their perceptions and their reports against what you're seeing in the skill spurts and the skill changes. Just curious as to whether you have any kind of qualitative data or your thoughts on that kind of qualitative data, which I know is a bit different, and I know it's testing something else, but I think it'd be absolutely fascinating to see whether or not you see alignment in their perceptions and their thoughts of what's happening in their skill development journey mapped against what you've got in these really wonderful graphs.
Yeah, we thank you for the question. We don't have qualitative data, only this quantitative. But I think it will be interesting to look forward. And I'm going a little bit for what David was saying. I was wondering if we could group in this case athletes, young athletes, because we know when they start to be an athlete. And maybe though in the lower competitive levels, when we have a team of under 12 or under 14 players, there are always children or kids coming in and coming out, and maybe we can look at, okay, let me see what happened to the skill development of the kids that just started to play basketball or other sport, and what happens when a kid has 3, 4, 5 years of experience. Maybe this might be different. I don't know.
Yeah, I think, again, putting it kind of squarely in the sensitive periods framework, there's there's really a need for some sort of experimental study where you start children at different biological or chronological ages, and then you track them longitudinally. And therein lies the challenge, because ideally you would start them as soon as they're going to get exposure, or they would typically get exposure, and then you've got to figure out how to hold some people back and expose them later. And again, that's the massive challenge associated with doing like true experiments on this work.
But you'll only be able to do that naturalistically. You're not going to be able to tell to a parent, "Oh, I'm going to hold your child back so I can do my experiment with them."
Yeah. Not in the sport context, but you could probably do it with some other motor skill, like in a different context, in a school context,
Or
for
schools,
example, like a skill that most children are not going to learn.
Right.
And you use different. Again, age is obvious. It's the most obvious variable to use because it's the easiest in terms of grouping the children. But if there were another biological marker, that would be really useful as well.
Okay, I'm going to have to stop us because we've lost almost everybody here. I want to thank you, just to be clear at the very end. Thank you, Eduardo and David, both of you and your team. Wonderful work. And I love Matu's comment that, "Oh yeah, I'm going to assign this for my class right now." And your class is probably saying, "Oh no," but the recording for this, Matu, is going to be online, so you can have your students actually check in on the article as well, so they can read it and then hear from the authors themselves. So
yeah, and I will leave here my email, because if you want to chat or some suggestions, I'm more than happy to.
yeah, well, on the IMDRC website is your article, which will have your email as well.
Yeah.
But it might be good if you would send me a copy of the second paper, and I'll have them load that up on the website as well, if you don't mind. The one you referred to. Yeah, the one you pulled up and showed us again. Yeah, that might be, or at least the citation, so that people could know that, and I'll send that out as well.
I think if I put it on the chat is okay for you.
Yeah, okay, the check comes back to me. Okay,
Okay.
great.
So zoom is
Zoom.
okay. Is transferring.
There we go. Whoa.
Okay.
All right. Thank you very much. That's great. Wonderful. All right. Well, thank you all.
Thank you
And
so much.
I
Bye-bye.
appreciate
Well
you.
done.
Yes.
Thank you for that excellent work.
Yes. Excellent. Absolutely excellent. I'm going to stop recording now. So, and I will send you the link to the recording so that you can critique yourself.